6 major companies built 7,377 aircraft at 10 factories on 2 continents. More service personnel were involved in flying and maintaining the Lancaster than any other British aircraft in history. During early 1942, it was decided that some of the bombers should be produced in Canada, where they were manufactured by Victory Aircraft in Malton, Ontario. The Avro Lancaster. From 2 to 4 engines. In the 1930s, the Royal Air Force was primarily interested in twin-engine bombers. Power limitations were so serious that the British invested heavily in the development of huge engines in the 2,000 horsepower class in order to improve performance. During the late 1930s, none of these was ready for production. Both the United States and the Soviet Union were pursuing the development of bombers powered by arrangements of 4 smaller engines. The results of these projects proved to have favorable characteristics, such as excellent range and fair lifting capacity. Subscribe to our channel and get notification when we release new episodes. Accordingly, in 1936, the RAF also decided to investigate the feasibility of a 4-engine bomber. British aviation company Avro decided to submit its own design for a 2-engine bomber. The resulting aircraft, named the Manchester, entered RAF service in November 1940. Although considered capable in most areas, the Manchester proved to be underpowered and troubled by unreliable engines. Consequently, only 200 were constructed, and the type was withdrawn from service in 1942. Avro chief designer Roy Chadwick had already been working on an improved Avro Manchester design, using 4 of the more reliable but less powerful Rolls-Royce Merlin engines fixed on larger wings. The aircraft, initially designated Avro Type 683 Manchester III, was later renamed the Avro 683 Avro Lancaster. The prototype aircraft was assembled by Avro's experimental flight department at Manchester's newly opened Ringway Airport and made its first flight on January 9, 1941. It proved to be a great improvement on its predecessor, being one of the few warplanes in history to be right from the start. Some of the later orders for Manchesters were converted in favor of the Lancaster. The 2 bombers shared various similarities and featured identical design features, such as the same distinctive greenhouse cockpit, turret nose, and twin tail. The designs were so similar that an entire batch of partially constructed Manchesters were completed as Lancaster aircraft instead. Based upon its performance, a decision was taken early on to re-equip twin-engine bomber squadrons with the Lancaster as quickly as possible. Construction. The industrial and military organization needed to build and operate the Lancaster was huge. 6 major companies built 7,377 aircraft at 10 factories on 2 continents. More service personnel were involved in flying and maintaining the Lancaster than any other British aircraft in history. During early 1942, it was decided that some of the bombers should be produced in Canada, where they were manufactured by Victory Aircraft in Malton, Ontario. The first Lancaster produced in Canada was named the Ruhr Express. The Lancaster was 69 feet 4 inches long, 102 feet wide, and 20 feet 6 inches in height. While not optimal, the aircraft was capable of flying the return journey home on only 2 operational engines and could fly very limited distances on a single running engine. The Lancaster benefited from a structure with considerable strength and durability, which had been intentionally designed to maximize structural strength per weight. This resulted in the Lancaster being capable of withstanding some levels of damage resulting from attacks by hostile interceptor aircraft and ground-based anti-aircraft batteries. An important feature of the Lancaster was its unobstructed 33-foot-long bomb bay. At first, the heaviest bomb carried was the 4,000-pound high-capacity Cookie. Bulge doors were added to 30% of Lancasters to allow the aircraft to carry 8,000-pound and later 12,000-pound Cookies. The Lancaster also carried a variety of smaller weapons, including the small bomb container, which held 236 4-pound or 24 30-pound incendiary and explosive incendiary bomblets. Crew positions. The standard crew for a Lancaster consisted of 7 men stationed in various positions in the fuselage. The bomb aimer was in the nose. His primary location was lying prone on the floor, with access to the bomb sight controls facing forward, the Mark 14 bomb sight on his left, and bomb release selectors on the right. On the roof of the bomb bay, the pilot and flight engineer sat side by side under the expansive canopy, with the pilot sitting on the left on a raised portion of the floor. The flight engineer sat on a collapsible seat known as a second dickey seat to the pilot's right, with the fuel selectors and gauges on a panel behind him and to his right. Behind the pilot and flight engineer, and behind a curtain fitted to allow him to use light to work, sat the navigator, his position face to port with a chart table in front of him. An instrument panel showing the airspeed, altitude, and other information required for navigation was mounted on the side of the fuselage above the chart table. At the end of the bomb bay, the floor dropped down to the bottom of the fuselage and the mid-upper gunner's turret was reached. His position allowed a 360-degree view over the top of the aircraft, with 2 Browning Mark II machine guns to protect the aircraft from above and to the side. The Avro Lancaster was initially equipped with 4 Nash & Thompson Fraser-Nash hydraulically operated turrets mounted in the nose, tail, mid-upper, and underside. The original tail turret was equipped with 4 Browning Mark II machine guns. All other turrets had 2 such guns. The tail turret was the most important defensive position and carried the heaviest armament. Ammunition for the tail turret was 2,500 rounds per gun. The Fraser-Nash FN-121 was a radar-directed rear-gun turret fitted to some British bombers from 1944. This significantly reduced operational losses. However, all radar and radio transmitting systems have the disadvantage of enabling enemy forces to locate aircraft by picking up transmissions. The mid-upper or top turret was surrounded by a coaming that provided a track for a cam-operated interrupter device that prevented the gunner from shooting the tail of his own aircraft. The ventral underside turret quickly proved to be dead weight, being both difficult to sight because it relied on a periscope which limited the gunner's view to a 20-degree arc and too slow to keep a target within its sights. Combat. On March 10, 1942, the first bombing mission was conducted over the German city of Essen, North Rhine-Westphalia. While the Lancaster had been designed to conduct nighttime operations, daylight raids were occasionally performed by the type as well. The existence of the Lancaster was revealed after a daytime raid upon an engine factory in Augsburg on April 17, 1942. Due to the high loss rates typically involved in such operations, daytime bombing missions were performed sparingly until the Allies had achieved a level of aerial supremacy over the Axis powers. On October 17, 1942, another audacious daytime raid was carried out by 90 Lancasters of No. 5 Group, bombing the Schneider Works at Le Creusot, France. Only 1 aircraft was lost during the course of the mission. Throughout July 1943, large numbers of Lancasters participated in the devastating round-the-clock raids on the city of Hamburg during Air Chief Marshal Harris's Operation Gomorrah. Sir Barnes Neville Wallace was an English scientist, engineer, and inventor. He is best known for inventing the bouncing bomb and earthquake bombs, which were dropped by the Lancaster on certain missions. Royal Air Force 617 Squadron was created to undertake Operation Chastise, the raid against the Ruhr dams. This unit was equipped with special Lancasters, officially designated the Type 464 Provisioning, which were modified to carry the 9,250-pound upkeep bouncing bomb filled with Torpex secondary explosive, 50% more powerful than TNT by mass. The name is short for torpedo explosive. Torpex proved particularly useful in underwater munitions because the aluminum component had the effect of making the explosive pulse last longer, which increased the destructive power. During Operation Chastise in 1943, the Möhne and Ettersee dams were breached, causing catastrophic flooding of the Ruhr Valley. After the Dam Busters raid, 617 Squadron was converted to a high-altitude precision bombing unit in preparation for the arrival of Wallace's forthcoming earthquake bombs for attacking special and hardened targets. During the latter half of 1944, a series of high-profile bombing missions were performed by the Lancaster against the German battleship Tirpitz. 3 attacks, individually codenamed Operation Paravane, Operation Aviate, and Operation Catechism, were conducted against Tirpitz, which was anchored in a fjord in occupied Norway. The first of these attacks disabled the vessel, while the third mission was responsible for sinking the ship. Final roles. During early 1945, 33 Lancasters were modified so that they could deploy the 22,000-pound Grand Slam bomb, the heaviest conventional bomb to be used during World War II. It was also known as 10-ton test because of its weight. By the end of the war, 41 Grand Slams had been dropped on operations. Prior to the decision to carry out extensive modifications to the U.S. Boeing B-29 Superfortress to allow it to deliver atomic bombs over Japan, serious consideration was given to using the Lancaster with its cavernous bomb bay instead. Using the Lancaster would have required much less modification to the aircraft itself, but would have necessitated additional training for the U.S. Army Air Force's crews. U.S. officials wished to use an American plane if at all possible. The Lancaster conducted a total of 156,000 sorties and dropped about 682,000 tons of bombs from 1942 to 1945. Only 35 Lancasters completed more than 100 successful operations each, and 3,249 were lost in action. The most successful survivor completed 139 operations and was ultimately retired from service and scrapped in 1947. Adolf Galland, commander of German Luftwaffe fighters, considered the Lancaster to be the best night bomber of the war. In the post-war climate, the Lancaster continued to see use for several more years, during which a number of high-profile operations were conducted. Immediately following the end of hostilities, the Lancaster was used as a crewed transport aircraft, ferrying thousands of prisoners of war back to the British Isles from across the continent. The Lancaster continued to be operated in significant numbers until introduction of the new Avro Lincoln, which itself was a derivative of the Lancaster. The Lincoln was not available in quantity for several years following the end of World War II. In December 1953, the final Lancaster in service with Bomber Command was retired. In late 1954, the last Lancaster in active service with the RAF, an aircraft which had been used for aerial reconnaissance missions, is believed to have been retired. Today, there are 17 surviving Lancaster bombers in the world, but only 2 of them are able to fly. If you like these types of videos, subscribe to our channel and get notification when we release new episodes. For more interesting military history content, check out our video library.